Today we're going to see next topic. Uh, that is compute and math. So let's click this one. Um, Move on to compute. Okay. Before this compute, we see add in this section. So what is add? Add means adding two values. Okay. Means here it is optional that if you want to give an input or you can give the input or uh, can directly from this also. But it is like when the input is given, then only you should add the value, okay, for some condition. Or you should directly add the value, okay, whatever value you are getting from any source, okay. So we're having two sources, source A and source B. That means we're adding two values and storing in dest. Dest means destination, okay. For example, I take some memory here. This memory I can use. Value means some integer value or it can be a float value, okay. So I'm taking say integer value. So I can take this n7 colon 0 here and 1 next memory. I want to store this in other memory like n7 colon somewhere like this. Similarly, your other instruction was that subtraction something. This would be just type it, you'll get it. I change the memory location like 10, 11. Let's store this in somewhere in 15. Okay, so like this you can do this addition, subtraction, multiplication, division of your values. Let us see. Now I make this input on here. Here under this arrow, okay, less than symbol, here you can enter the value like 50. You can see 50 plus 0. Source A and source B are added and move in destination is in 7 colon 5. Okay, so 50 plus 0 is 50. If I add another value like 65 something, is added and move to destination. Okay, similarly, subtraction, if I take some 65 minus 10, 55. Okay, so we are also to subtracting the value. Now, here also you can see integer 5 and 7 colon 0 and 7 colon 1, okay, 10 and 11. So these are the results where it is stored. Okay, these are the memory locations where your values are stored. Okay, you can see the result here also in this table. Now, similarly we have what CPT. Okay, that is a compute. Okay, CPT. What you can do here in this compute. Destination is some memory where I can store the result. Say n7 colon 0, I want to store the value. Then I can write some expression here. Because I can take some memories. Let's say from n7 colon 21 plus n7 colon 22. So such expression you can write here. Into, okay, for star you can take into, okay, n7 colon 23, that memory location. And you can also do like n7 colon 24. So such expressions also you can write in using compute. Okay, let's see this result. Now I open this integer 5. So what are the memory locations here? N7 colon 20. This is an N7 colon 20. You can see the cursor. Okay. And from N21, N7 colon 21 to 24 is the address here. These memories you can modify like 50 plus 10 into 60 minus something like 25. Okay. So I give the input here. Uh, you can see what's the value we are getting here in N7 column 20, it is 2100. 50 plus 10 is 60 into 60 minus 25. How much will you get here? 35. Okay, 35 into 60. So you get this value. Okay, so these are we can do some calculations using this add, subtract, or the multiplication or this instruction. Square root. Negative means converting your sign. Sign means negative to positive, positive to negative. Okay, so these instructions are there. Now, source N7 colon 0 and N7 colon 1. Okay. Say yes. So here if I enter some value in N7 colon 0 like 25, so what value you are getting? Minus 25. Negative is converting your sign, okay, of your value. Okay, if it is positive, so it will convert it to negative. If it is negative, it will convert to positive. Like if I give minus 1, minus 25, you get plus 25. Okay, now, so this is about compute and math instructions. Similarly, we have other instructions like move or logical. Move means moving some value or some source to a destination. I can use it like some 500 value I want to set in some memory like N7 colon 10. I want to set 500. Okay, it should be always 500 into this memory. Similarly, I can use copy, paste, different ways I can use. Okay, like N7 colon 5 to N7 colon 15 somewhere. That is memory to memory. Here, a constant value I'm fixing. Okay, the 500 should be there in N7 colon 10 always. Okay, but if I want to make any changes in the value, I can modify in some memory, right? So that's why I'm taking memory to memory. And if one more example, like if I'm having 16 inputs, 16 outputs, 16 inputs means 16 digital inputs, 16 digital outputs. So 1 to 1 means first input, first output, second input, second output, like that. I have to make this outputs on. Okay, 16 outputs on with each input. So how many rungs you have to take? 16 rungs. Okay, instead of that, you can use a move block, and here you can use a word address for your input. That is I column 1.0. I'm not using by any. Okay, by 0 to 15. I'm just giving only up to word number 0. Okay, and I can do this into the output. Say O column 2.0 word address. Okay, so at a time we can activate 16 inputs and 16 outputs, so 1 to 1. Okay, so here it is moving bit to bit. Okay, so it's just like a copy and paste. Copy some value and paste it in some memory. So here you can see in N7 colon 10 we are getting 500. Okay, if I want to make any changes here, is it possible? Not possible. If I double click and try to make any changes like 1000, It's not taking, not accepting. Okay, not accepting. So to make this change here, okay, instead of 500, I want to make it 1000. So I have to go offline. Okay, I should be in offline. I have to make this change in offline, like in source 1000, enter, and then again download here. Okay, so this is one case. Okay, if you have to make any changes in this fixed value, okay, you have to again download the program. You have to make change here and download the program again. Whereas in this case, in second case, N7 colon 5, I no need to download. See, I will make some change. It is moving to the destination memory, right? If I double click and change, so do I need to download here? No, I don't need to download this block again. In the previous case, I need to download the total block again. Okay, so there is one thing we have to understand here. Okay, how you can use this move. Similarly for this inputs. Okay, if I open this input file and output file, so I colon 1.0. Okay, that address I have taken here. Similarly for destination I have taken O colon 2.0. So when I make any input high here, 1, you can see that particular output is going on here. Similarly, the next one, so it is moving data 1 to 1. Okay, number of inputs I make on, the same output address will go on there. It's like 1 to 1. So you no need to make 16 runs. Okay, you don't need to take 16 runs for that. Simply you can use a move instruction for this. Okay, and the last one I make one, the last one will be on. Okay, so this is how you can use this move instruction. In this move instruction, if it is a word or double word, okay, so it is moving value bit to bit. Okay, this is what is happening in this move instruction. Now, these are what the move. Similarly, we have AND or XOR. These are different move instructions like A and D. It is bitwise, handing of two inputs. Okay, like if I make N7 colon 1 and I take N7 colon 2. Storage in N7 colon 20. Yes, yes. Means here it is adding these two memories. So whichever bits are high and low, according to that, it is ANDing. ANDing means AND means what? When the two inputs are on, then only you get the result as 1. If any 1 0 is there, so result will be 0. Okay. So you can see this result in this memory and you can convert this format into decimal. Sorry, in binary also you can convert. So 7 column. Let's just change the addresses here. 0 and 1. So this is 2. Because I'm converting into binary format to understand the concept. So radix as a binary. See, here I make some bits high. This one 1, another one 1, and make it as 1. Let's enter here. And this I make 1 here. And 7 colon 0 memory here. Okay. This N7 colon 1 also I make some bits high. This is 1 1, so you are getting 1 as a result. Okay, 1 0, you are getting 0 as a result. Again 1 1, you are getting 1. So here I make this 1 is also 1. Here I make this 1. Okay, so wherever it is getting and condition true, okay, 1 1 1, so we get that output here. Okay, if you convert this into decimal, you can see what value we are getting, 8338. Okay, so what are the above values there in that, it is ANDed and then give the result here. Okay, so it can be another value also, like this one be 1, this one should be 1. Okay, now you see the result. Okay, this is another value, 8406. So when you are adding these two values, you get this result. Okay, which is stored in your destination. So that way, you can do the ANDing of two values and move it to another destination. So similarly, we can do for OR, XOR, NOT here. NOT means reverse. Okay, all zeros will become ones, ones will become zeros. Okay, clear means clearing some memory. I want to clear that memory and 7 colon 2. So which memory you want to clear, you can give that address. Okay, CLR. Which memory you want to clear, that memory, when you give the input, you should clear that memory. Okay, so this way you can take this clear instruction. It is about the move and logical. Now, our next topic is program control. So what is this program control? Program control means if like I'm having two conditions, okay, so two different programs, but I want to execute any one program, not both the program. Means if the first program is executed properly, you should skip the second program. Okay, so that way also you can control your program. That is called jump instruction, jump and label. So when you are using jump, you have to use a label. Okay, so for example, I'll take some hello. It's IC and JMP. Okay, jump, JMP is a jump instruction, LBL means label. Okay, I take this jump. Now, when I take one input address, um, for jump, we're having addressing format Q2 colon 0. Okay, Q2 colon 0. Then between this jump, I'll add some inputs and outputs like XIC, OT also, right? Similarly, XIC, one more run. Here I take LPL space XIC space OTP. Okay. Now I take these inputs here. I change the input address bit to 1, 2, 3. Okay. Now here we take the output address. Okay. Now for label, you have to use the same jump address, that is Q2 colon 0. That is Q2 colon 0. Okay. Say so from where or how many rungs you want to jump. Okay. So that's why we have to use a label. After label, whatever the logic is there, it will continue as it is. Okay. So I download this. So yes, yes, run. Yes. Now, right now the jump input is off. So the jump is not activated. Okay. Now I made the start input on. This output is working. Now second input, second output is working. After label, when I give this input, that is also working. Okay. Now I make them off. So observe here what is happening. Now I right click and toggle bit here. Now I activated the jump instruction. Now when I do this input, start input, is the output going on? No, right? Similarly, if I activate the second input, output is on? No. Now after label, when I activate the next input, yes, the output is working. Means when you activate a jump, so whatever the outputs are coming under this jump and label are skipped. Okay, it's not executing those outputs. If I make the jump input off, jump is disabled. Means if the previous condition is not executed, if that condition is having some error and it is not executed, so they should execute this outputs. Okay, this logic. So that way I can use this jump instruction. Now when the inputs are on, the outputs are on here, right? When the jump is off. Now I activate the jump in this condition. Is it making the outputs off? No, it does not make the outputs off. Instead, it holds the outputs on. So if I toggle bit and remove the inputs also, still your jump instruction is holding your outputs on. After label, it will be on or off as it is. Okay, but your outputs are still on hold. Now, if I make the jump input off, as the inputs are off here, your outputs also goes off. Okay, means jump and label. So whatever the status of your output is there, means it was in on or off condition, that will be on hold. Okay, so that is how your jump instruction is working. Okay, now this is about the jump instruction. Next, we are having MCR. MCR means master control relay or reset. Okay, in some PLCs it is known as relay, in some PLCs it is known as reset. So how to use this MCR? Master control means you see some emergency buttons, right? Emergency button means when you press that button, it should stop your machine immediately or your process immediately should shut down. Okay, for such application I can use this MCR zone. So in this case, you have to use one MCR with one input. You can see MCR with one input I am taking from where to where you want to control, means how many outputs you want to control or rungs you want to control. After that rungs, you have to connect one more MCR without any input. So this is called one MCR zone. So let's see what happens here. So that emergency button is generally a NC type of push button. NC type means it will be, your input will be on. So within this MCR zone, when it is on, it is allowing your outputs to work. That means your push button is NC type. So when you press that button, what happens? It opens. When it opens, what happens? Your input goes off. MCR input goes off. Now you can see what is the status here. All the three outputs are off, right? But your inputs are still on and your outputs are off. Now, if I check the error and rectify the error and reset the button, it again becomes closed. So this input goes on. When the input is on, again your outputs are executed step by step, like one by one, right? Because your CPU is executing your logic from top to bottom and left to right order, right? You can see if I make the input off, when I press the button, it opens, so it goes off, and all the outputs are off immediately. So this way it is controlling your process. Okay, this is called MCR instruction. Now, so